Welcome to Hic Sunt Draconis, Here Be Dragons. So, I am going to go over some of the general arguments that I see from people who are unhappy to have UFOs or UAPs debunked. Now, where most people assume I just outright dismiss anything that isn't said by the scientific community and simply hate people that challenge the official stance of the scientific community, I want to say that this is as far from the truth as you can get. We are able to put our faith in science simply because of how rigorous the process is. And a very important process is challenging that science. We are always trying to make the first guy that came up with a hypothesis into a liar. In fact, you can get an award and lots of money for doing just that. This is why we absolutely know that our physics is 100% accurate for the level at which it is being applied. Now, I encourage everyone to always challenge the science when you can. Now, there is a difference between challenging the science by saying, I wonder if it is still right in this scenario, and then performing multiple experiments to prove or disprove if you were right. However, a lot of people in the pseudoscience community just don't do this. They simply state the science is wrong, and then they spread that message to as many people as possible. That is not how science works. You need to conduct multiple repeatable experiments. Along with your statement, you need to attach how you conducted the experiment, so that others can replicate it, along with the data you got. Simply saying, ships don't disappear over the horizon, it's just a mirage, isn't proving anything. Go get the equipment and perform an experiment to prove that it is a mirage, and not really a ship going over the horizon. You can do this in many ways, such as using IR or thermal, which wouldn't be affected the same way as light in a normal optical camera. I do truly enjoy looking at these challenges, then finding the information for myself to see if they are correct or not. I learn a lot in the process, things I never knew and that I never anticipated I would learn. So please keep challenging science, but also challenge it using the scientific method and research your claims and try to understand everything you're talking about rather than simply dismissing the parts that don't line up with your message. Now, on to the arguments. Number 1, other star systems could have other elements, meaning they could have some type of fuel that lets them do things we cannot. One big source of this is from Bob Lazar regarding element 115, which is only man-made here, and no stable version has ever been found in nature, nor have we ever created one. He argues that just because we don't have it in the solar system doesn't mean it doesn't exist elsewhere. Well, that is wrong. First, we have spectrographs, which means we can look at other galaxies and star systems and see exactly what they are made out of. How does this work? Well, ever seen fireworks? You know how we get different colors by adding different chemicals? They all let off a different spectrum of light. This is the same concept. We look at the light spectrum coming from that galaxy or star system, and it tells us what it is made from. A neat random fact is that we can also use the concept to tell us if something is moving towards us or away from us, and at what speed. The color of light is determined by its wavelength. A longer wave is more red, and a shorter one is more blue. So, something moving away from us stretches that wavelength, making it more red, and something moving towards us will compress that wave, making it blue. This is referred to as blue shift or red shift. And this is how we can tell if the universe is expanding and at which rate it is expanding. Now, you can hear the exact same phenomena with sound. It's called Doppler shift. You see that? That's what we're talking about. Now, you just apply that to light, and there we go. So, we do know what these star systems are made of. Now, as far as other galaxies and other star systems having other elements, no. We know all possible elements, even the ones that have not been observed yet. An element is defined by the number of protons in its nucleus. There are variations in elements called isotopes that have varying numbers of neutrons, but again, the number of protons is invariant. These are states of the atoms where it may have a small deficit or surplus of electrons. This is called ionization. The number of protons is still invariant. That is why you see the numbers on the periodic table. That is the number of protons, which identifies which element we have. For example, let's go with vanadium. Since I just got a vanadium nozzle for my 3D printer, it's really cool stuff and it is super hard. So, vanadium has 23 protons. Anything with 23 protons is vanadium and will still have the same properties as vanadium. If we add a proton to vanadium, then we have chromium. If we change the number of neutrons, that is what an isotope is, and then we have a different isotope of vanadium. And it just affects how heavy the element is. But it is still vanadium, and it still has the same properties as vanadium. Electrons affect the charge of the atom and determine how likely it is to interact with other atoms. This is called ionization. I'm sure you've heard of this. But even if it has been anioned or ionized, it is still vanadium. The highest element we have seen is organosin, number 118, and we had to make it, as higher number elements are not stable nor exist for any more than a mere milliseconds. So, we won't find them in nature. The largest element we will find in nature that is stable is number 82, known as lead. When the mass number of the atom is greater than 82, the atoms are not stable because of the level of binding energy. The repulsive force between the particles is more. The atom splits because of the force of repulsion between the particles, and new elements are formed as they reach a new configuration, which is stable. Finally, elements are not created in stars, therefore are not local to star systems. They are created when stars go kaboom, which is a supernova, and this cloud of elements expands far out, a very, very long way, and keep expanding out until captured by an object with sufficient gravitational pull. So even if a new special element was somehow formed, it would be found in many different systems. So you see, the argument that other star systems might have completely different elements with completely different properties than the elements we have here makes absolutely no sense. Next, our science could be wrong, and aliens could have completely new science. Yes, sort of, but science simply gets added to. It is never wrong and is never replaced completely. Newton's version of gravity got replaced by Einstein's. However, Newton's gravity still works just fine here on Earth. Einstein's gravity works better when it comes to astrophysics. And I am sure a more detailed version of gravity will show up that works with quantum physics. Let's look at light. The speed of light is the speed of light. It will never change. But we will add more numbers after the decimal points. The expansion rate of the universe, the speed of light, and not being able to travel faster than the speed of light are scientific facts and will never change. Yes, we can get around the speed of light by moving space itself, but that still has its own limitations. And since the universe is not only continuously expanding, but also increasing the rate of its expansion, it doesn't matter how much faster you go. The rate of expansion still keeps increasing, so much that you will never get to another group of matter or star systems. But so many instruments witnessed it. No one is saying that UAPs are not there. What is being said is that the chances of them being space aliens is so very slim that to automatically jump to space aliens as a cause is just nuts. Even though it is also very, very slim, there is more of a chance that these are simply time-traveling humans. Why doesn't anyone go with that theory? And then, but so many pilots saw it, you just can't dismiss everyone. Again, no one is flat out dismissing what was seen. It could be anything. However, witness testimony is not considered scientific evidence, but we can use it to help gather scientific evidence. Here's the thing. Science prides itself on not just high accuracy, but repeatable high accuracy, and humans are notoriously inaccurate. When you have multiple witnesses, you rarely get the same report from each person, and even small differences can vastly change what an object could be. Humans are also really bad at accurately remembering what we saw. I go into this in the Bigfoot video. But we control what we saw, and our minds can modify what we saw, which means we ourselves can change our own memories, even without realizing it. Even if we don't change our memories, we are very good at seeing pareidolia, or seeing something that looks like something else, because our brains are just really good at finding patterns. That is one way we survive. We are also susceptible to optical illusions and confirmation bias. Plus, not to accuse anyone, but a lot of humans have absolutely no issue with lying, especially when it results in fame and money. So, even though we believe these witnesses, we cannot use the testimony as physical scientific evidence. Even if we don't like it, having a set line of what is and is not acceptable, regardless of the situation or our personal feelings, is exactly what makes science so accurate and so convincing. That is it for the arguments. The rest of them are more or less just random insults rather than anything real, such as how can you ignore this, and this, when most of this has never been seen. A lot of the responses I get with supposed proof attached, and I do get a lot, are simply statements from someone that someone heard someone else talk about, and I can't find them anywhere, or if I do, they are not anything like what the person is claiming. One thing I've noticed is that people get very offended when you say it can't be aliens. Almost as offended as if you walked up to a Christian and said, God is fake. Why? I mean, this is just demonstrated bias. They want aliens to exist. And I understand why. I do get it. But still, what it shows is that no matter what evidence is brought, they won't ever accept it. The same goes for flat earthers. Give us evidence. We do. Here's pictures of the curvature. That's just due to the fisheye lens. One flat earther even actually said, astronauts aren't lying. They really think the Earth is round because that is what they see, as the helmet glass is curved. It just goes to show that no matter where you are on the anti-science fence, no matter what proof you are given, you won't agree. Now, let's think about this. UAPs. If aliens are acceptable, why not time-traveling humans? Why not time-traveling apes or time-traveling dolphins? Maybe they are superheroes or even Iron Man. You really think someone can't build a flying suit? Oh, what's this? And this, and oh my, that's a freaking flying bathtub. Maybe they're Greek gods or Roman gods. Maybe it's Buddha or actual God, as in the Christian God or Jewish God. Maybe Satan. Angels, demons, spirits, ghosts, secret flying whales that hide in the clouds so we never see them. They have special light-bending skin. What about super advanced military aircraft carriers? You know, like this one from that movie. You give these options, which are really more plausible, sort of, than space aliens, and people laugh at you. Why are they so sure that they are space aliens? They denounce possible human activity right away, even though humans are constantly shown to be at fault. Flying men, drones, weather balloons, stealth aircraft, drone displays, hypersonic aircraft, satellites, rockets out of control in the dawn of sunlight. It is amazing how many people with an accounting degree, an art degree, just basic college education, or simply a high school education, or even no high school education at all, can know so much more than people with multiple doctorates and years of experience in astrophysics or aerospace. Amazingly, there is an explanation. It is called the Dunning-Kruger effect. The Dunning-Kruger effect is a cognitive bias where people with low ability, expertise, or experience regarding a certain type of a task or area of knowledge tend to overestimate their ability or knowledge. Some researchers also include their definition the opposite effect for high performers, their tendency to underestimate their skills. Basically, the less you know, the more you think you know. It's just something to consider. So, have a good day.